So what is the wavelength given? Lambda 400 nanometer, work function 2.2 electron volt. A particular electron absorbs photon and makes two collisions before coming out of metal, assuming that 10% of extra energy is lost to the metal in each collision. Find the kinetic energy of this electron as it comes out of metal. Under the same assumptions, find the maximum number of collisions the electron should suffer before it becomes unable to come out of metal. Again, the theoretical, what all we discussed theory, that only is being asked here. Now, here is what the light will be incident. Let's assume that. So what is telling, and this is the electron. So first, what is the energy of photon? What all energy of photon is there? So first we'll calculate the energy of photon. Then what is the kinetic energy it will acquire? K max equal to SC by lambda work function. Let's get into everything in electron volt, so that will be easy for us. HC, I'm taking 1, 2, 3, 7, 5. In books, sometimes they may give like this, take SC. So substituting that, I'll get maximum kinetic energy of electron equal to how much? Oh, the energy of, sorry, not this one. Huh? Wait, this one. The energy of photon will calculate, which is equal to Hc by lambda. I just use calculator. I'm ending up with this approximate 3.1 electron volt. Now what is the condition given? This much of energy what happen, the particular electron will get it. Now is it all this energy will be utilized? So first what will happen? It will, after getting this 3.1 electron volt, the electron will start moving. It will encounter collision. Collision I'll just show by red. It will encounter one collision, and after collision again it will move. Again it one more collision. Assuming that 10% is lost to the metal collision, find the final kinetic energy of electron as it comes out of the metal. As it comes out of metal, no, it will encounter two collisions. Now here, when it arrives here, it will have energy, say here it was EP. After one collision, it will become E1, then this will become E2. Now when finally it emerges out, it will have kinetic energy K. Now what should happen to that energy now after first collision? Energy of electron will say. Energy of electron after interacting with photon, let it be EP. 10% is lost. 10% means how much we can write it as 3.01. No? We can't neglect this. 3.09. 10% in that if we remove it, 2.78 electron volt. Then again in this 10% of energy will be lost, 2.5 electron volt. Finally, it is having 2.5. So what is the kinetic energy of that will be? E2 minus work function, 2.5 electron volt. What is the work function? 2.2 electron volt. So this will be 0.3 electron volt. This is the kinetic energy of the electron. Here is what? First collision. This is the second collision, and this is surface of metal. Able to imagine? So students, some students, I don't know what will happen, some books also, or some books they're given. First what will happen, don't subtract this work function. First, what happens? The electron will gain energy from photon. When it arrives at the surface, then that work function will come. So what students are doing, directly first they are removing this work function from here. 3.09 minus 2.2 electron volt. Then remaining how much? That with that kinetic energy, it encounter course. No, no way the work function will not come into picture. First, the electron will interact with photon, it will gain energy. After is it all the energy from photon be transferred? This is hypothetical, practically not possible. Tomorrow's class, I tell you what happens if electron completely absorbs photon. What will happen? So it's hypothetical. Partially it will absorb it, not completely. This is hypothetical. Let me assume completely here. Then first it will absorb the energy of photon, then encounter collision when it arrives at surface, energy greater than work function will come out. So don't subtract this work function first from 3.09, then get in problem. It will be wrong. And now it's telling under same assumptions, find maximum number of collisions the electrons should suffer before it becomes unable to come out. So 2.5. So in that you remove it. So how many collisions that will occur? I think I'll continue the problem now. Now the electron will interact with this. So first one collision will occur. I think similar way. Second collision, third collision, fourth collision. So here we have to check it, how much of energy that one. After fourth collision, we'll see what is the energy of that one. So there's the first collision, second, third, and fourth. So here what was the energy of electron? It was EE, then E1, E2, E3, E4. So number of collisions, first, second, third, fourth. I did calculation. You are supposed to work out here. So you calculate E4. The E4 what will happen will be less than 2.2 electron volt. You can see from here only E2 is how much? 2.5. 10% of that you make it, you'll get E3. 10% of that you make it, then E4 will become less than 2.2 electron volt. So how many collisions occurred here? 4 collisions. After 4 collisions, the kinetic energy of the electron, what happened, will be less than work function and it fails to come. What will happen to this electron? It will just move randomly and keep on collide till it will attain the temperature of the metal, thermal agitation. The mean kinetic energy it will acquire. So this particular photon, what happened? This electron, though it interacted with photon, it failed to come out. So therefore, all incident photons will generate photoelectron. The answer is no. That's what they meant it to say that one. All the incident photons will not emit photoelectrons. Practically, sir, what is the efficiency? I think previous problem I just gave. Practically till now the efficiency is around 22%, almost maximum. In the research level they've found it 22 or around 28, but solar cells what we use in our home applications, so it is around only 11%. The efficiency is in fact very poor. And all these are theoretical. In SC Verma, you're almost having some best questions are there even in Icon, even in Singage. Work out this one. So first have a theoretical idea clarity. The numericals will be of this kind. And now this ejected electron, what will happen to it? If I bring magnetic field, it will revolve in circular path. If I bring external field, electrostatic field move. If I bring gravity, parabolic path. I think numerous ways of again testing questions here. Photoelectric effect idea is very less. Now we'll go for tomorrow all the mixed concept here. So we'll take, I think time is there. We'll see that. So number of collisions, we'll say like a, I need time. Okay, tomorrow I'll continue.